And fourth up today is another moments practice question. So have a go at this one. Okay, so the first part of the question asks you to state the principle of moments. The principle of moments says that if an object is in equilibrium, then the sum of the clockwise moments on it is equal to the sum of the anti-clockwise moments on it. And then next, calculate the moment of the rider's weight about B, give an appropriate unit. So here is the rider's weight, and there's B. So, which method are we using? Well, we can see nice right angles in there, so let's just check. So if we extend the force arrow out there, and there's the point we're interested in, and so it's this distance. Do we know that distance? Yes, we do. And let's just do our check. We've got a right angle there between the force and the distance. So that's good. So we can just do, so there's the driver's weight times the perpendicular distance, and so that's 273, not rounding, but actually it should only be two significant figures, so we should round to 2 sig fig there. Then the next part of the question asks us to take moments about B and thereby calculate the upwards force exerted by the road on the front tyre at A. So let's draw that force in there. And that, of course, is a normal contact force exerted by the road. And at this point, we'll just note that there is, of course, another normal contact force exerted by the road on the back tyre, but we don't know that they're the same size. In fact, they're probably not. Okay, so we are taking moments about B though, so we can ignore this one. It's not going to cause a moment. And then we notice that once again, all the distances that we've got marked, they're all perpendicular distances, so that's great. Okay, so I'm going to attempt to squeeze it in up here, and I'm going to call this force N. So in the clockwise direction, it's just N trying to turn the bike that way. So we get N times the perpendicular distance. But then in the anti-clockwise direction, we've got the weight of the bike itself and also the weight of the driver trying to turn us anti-clockwise. So there's the weight of the bike itself, and that perpendicular distance is 0.60. And then here's the weight of the driver. And this is the bit we've already done. Okay, and leaving you to do all the algebra there, you should end up with a force of, but rounding to two significant figures, 720 newtons. And predictably, the last part of the question asks us to work out the force at B, so I'm going to call that one, for no particularly good reason, C. And at this point, it's just become a simple forces question. So drawing a very simple diagram of a free body diagram of the bike, we've got N upwards, which is, I'm going to use a rounder because it's not going to make any difference, 720 upwards, and then we've got C upwards, and then we've got the weight of the bike downwards, and we've got the weight of the driver downwards. Bike is in equilibrium, so the total upwards force has to be equal to the total downwards force. Oops. And so once again, that's going to give you, let you do the algebra. Oh, and do I get three significant figures? Yes, I do, because I've got to the nearest 10 there. So that's my answer.